today? Functions, right? We're doing relations and functions. Here's our topic for today. This is some cool stuff. I like functions. Functions are one of my favorite things in math. Mainly because I like graphs, I like graphing things. In fact, we might be graphing something today. So let's go ahead and pull a coordinate plane here. Alright, I think I am set. A couple minutes before we start. See who else is going to jump on and join us. But relations and functions today. Going to be a lot of vocabulary words coming your way. What they mean. And this stuff is not going to go away. This stuff is going to carry you through however much math you get into. It's going to be there. They use these for statistics, they use these for trig, they use this for calculus, they use this for everything. So functions are extremely important. I also think they're kind of fun. All right, so before we get into the math behind all of this, we need to understand our key terms. We got to speak the language. And there's going to be a lot of just kind of new terminology that's going to come out, and it's not going to go away. So today, if you take notes on anything, it's mostly terminology, introduction to what functions and relations are, and kind of how they are represented in the world, and go from there. To start things off for the work today, you do not have to turn in graphs. So I asked you to do, what is it, page 403, 1 to 21? 403, 1 to 22, sorry. Do not turn in your graphs. Draw your graphs, but I don't want to see them because it's going to be you taking a picture of things and sending them to me, and I'm just going to get cluttered. For science, the project about making a quiz, is there an amount of questions we need? For the chapter, make it 25. Jason, so 25 for that, if it's for the chapter. And again, I would suggest for science knowing your terminology too. There's a lot of complicated words in that chapter that are probably new to you in science. So if you have questions on science, please feel free to ask as well. You can email about those. I am working on trying to figure out how to do something with Punnett squares that I can see easily, because you are drawing pictures for those as well, and I really don't want you taking photos and sending me a bunch of photos because they're tough to read, and I think just the process of taking the photo and finding a way to upload it and send it to me would be good. It is key terms. Oh, the key term quiz, about making a quiz? The quiz is about key terms. Well, you're not going to have... I think it might be a focus on the key terms. Science is posted on the website. like it's always been. I'm not sure if I can bring that up right now. I gotta remember what I wrote for the science thing. It's been a while since I posted this. So you're on Intro to Genetics. If you're talking about the key term quiz, I think it's only going to be, I don't remember how many is on this one. It's not going to be more than 16 questions on the quiz, like the matching thing. So that's what you're talking about. If you're talking about making the review game, I'm not exactly sure how you're going to share it with other people and stuff like that. Try your best, be creative with that. But I want the main focus to be on the key terms of that. To get 25 questions, though, you're probably going to have to think outside the box. You can have like the same answer for different things. You can word it differently and things like that. But I want you the focus to be on the key terms. So hopefully that answered your question. Science is on the website, James. I can show you what I see on the website. This is the editable. This is my version of the website. But science is all posted here, and your assignments are down here. Like always, and that's blown up here. If you want to pause the video and read this. There are some activity labs to do. Do it with someone in your house or a mirror. You could probably do it by yourself with a mirror, but you're going to have to look at that. The Punnett Square packet, I'm trying to find a way to reintroduce that to you. And I'm not sure, I might just put on like, hey, here's a live stream on how to do some Punnett Square problems and show you how to do them. They're kind of fun. But again, it's going to involve you drawing things, and it might not be the easiest thing to type up and send me. And for science, we're looking at the end of the month, if you can get it to me, which is like 9 days. But if you need more time, let me know, and I can extend that. I know some people get through things pretty quickly. Some people are spending pretty much their whole day doing schoolwork. Mine says stuff is restricted. All right. I will double check that it's shared with you. I thought I shared it with everybody, but I will double check. James. The other thing I'd ask you to do, James, is to double check that you're in your school account when you look at them. But if your name is showing up as James Diallo in this chat, I feel like you already are. Just cover your bases. When I'm done here, I will reshare those with you and do it. I probably miss more people than two. Normally, I only miss Anthony Kasab, and he mentioned it yesterday. But if I'm missing you, I probably miss more people too. Any other questions about science right now? If not, let's go ahead and start relations and functions. Turn our table to math here. And again, there's going to be a lot of key terms that you need to deal with. So we're coming over, yeah, we're looking at chapter 6. At least you should be. Just some key terms. First key terms. If you're following along with the PowerPoint given you, the first word that you need to know is relation. It's right there. But this is a relation. Now, how this works is a relation is really simple. It is a set. So it's a set of ordered pairs. That is a relation. That's all it is. That is the definition. Sets, if you're not familiar with set notations, we use squiggly brackets to denote sets. And inside these squiggly brackets is just a list or a rule or something to follow, where it just lists a whole bunch of individual things that are called elements, and it's just a list. That's all that's in here. So we can have a list of ordered pairs, like 0, 0 is an ordered pair, 0, 1 is an ordered pair, negative 1, 2 is an ordered pair, negative 3, 5 is an ordered pair, and then that might be the end of your relation. It just might just be that. That's what a relation is. It's just a list of ordered pairs. It's not too big of a word you need to know. Function, on the other hand, is a specific type of relation. But staying on with relation, in your ordered pairs, you also have the word domain, and you also have the word range. A domain are your x values. So this is your set of x values, and this here is your set of y values. And again, they're sets, so you have squiggly brackets around them. And looking at this relation here, all the x coordinates are part of the domain. So that's 0, 0, negative 1, negative 3. And because we have two zeros, we're not going to rewrite both of them. That's redundant. We're not going to repeat that. So we're just going to write it as this. So this here would be your domain for this. Your range, however, is your set of y values. And again, we don't want to repeat them. But this is just your second coordinate. So we have 0, 1, 2, 5. And we just list them. So they are just lists. So relation is just a list of ordered pairs. The domain are the x values to those, and your range is the list of y values to those. Other terms that you're going to come up with is that these x values in the domain. So the domain is the whole set. So the domain is the set. One element equals an x value. And x value is the same thing as an input, which we'll talk about later too. So domain goes with inputs. So a domain is just a list of all your x values. It's just a list of all your inputs. And again, it's just terminology you're going to need to know. Range is also a set. So it is a list of things. It's more than one number unless your range is only one number. Or you could have a null set, which is there is no range to this, which is possible. It's just unlikely because you don't really have a relation. But your range is a set, and one element in this set is equal to your y value, and these are going to be your outputs. So this is your input, this is your output. If I put in a 0 to my relation, I either get a 0 or a 1 because those are the possible pairs. If I put in a negative 1 to my relation, I get a 2 because that's what it's paired with. If I put in a negative 3, I get a 5 because that's what it's paired with. So they work together to form this relation. So domain are your x values in your inputs, range are your y values in your outputs. So if you want to clear that up, we can say domain equals x values in your ordered pair, which also equal your inputs. Range equal your y values in your ordered pair, which equal your outputs. Okay, so just again, it's terminology. You're just going to have to get used to using it. Next thing you need to know is a function. So a function is a specific type of relation. And these are the relations that actually mean things and we can work with because they model real life situations, whereas opposed to just normal relations don't necessarily do that. A function is a relation, and this is a bit confusing at first, that assigns one value in the range to one value, or to each value. I guess this is how I said it, to each value in the domain. Now to clear this up, I did put a couple tables here. We have x and f of x. F of x equals y. They're the same thing. This is pronounced f of x. I'll talk about it later. And if I have a table here, and I say this here is my domain, because they're my x values, right? That's my domain. This here would be my range, because they're my y values. Remember that equals y. This is read as f of x, by the way. So it says f of x equals y. They're the same thing. F of x is going to be your output as well. This here is just notation. It really means a function of x. So it's telling you that it's a function. So it's a little more information than just saying y, but these things are interchangeable. So you have your x value and you have your y values, or your f of x values. Right? If my x value is a 2, and a 7 maybe. So if I put in a 2 to my function, it gives me a 7. So what that's saying is your function normally is a rule, and is normally denoted as a machine, right? So you have an input goes into your machine, and this will be my function. It goes through some kind of rule, such as, I don't know, multiplied by 2, add 1. Something, I don't know, well, this was 2 to 7, so multiply by 6, or multiply by 3 and add 1 would be your rule. And then you get an output. So if my function here was that, that's what it would get. You have an input, then you have an output. If your function put in a 2 and you got a 7, that's allowed. However, if it puts in a 2 and it gets something different, like a 9, that's not allowed for a function, because 2 already gives you a 7. That would be like, you need to know what you're going to get out for what you put in. If you put something specific in, you better get something that you know coming out. Here, I have 2 different inputs. So if I put in a 2, I may get a 7 out, or I may get a 9. I don't know. I'm getting one of those 2. However, if I just said you put in a 2, you know right now you're going to get a 7 every time. So 2, 9, and then I give you another example here. If I put in a 4, I get a 3. I just made them up. Here, this is not a function. It's still a relation. This is a relation because it is a set of ordered pairs, right? 2, 6 is an ordered pair. 2, 9 is an ordered pair. 4, 3 is an ordered pair. You can see how they become x terms, y terms, and if you had the graph, you could graph them just by plotting the point. This is a relation, but it's not a function. And that's because if you put in 2, you could get more than one outcome. So it assigns one value in the range to each value in the domain. So here your domain is 2. If I put in 2, I could get a 7 or a 9. It doesn't assign one value, it assigns 2 values to it. Don't get that confused, because you are allowed to have something like this. And this is a different function. Again, my input, I need one output for each input. So if I put in 2, I get 7. If I put in 3, I could also get 7. If I put in 4, I could get 3. This is a relation, and it is also a function. And I know it's a function because for each input, I know what output I'm going to get. If I put in a 2, every time I'm going to get a 7. If I put in a 3, every time I'm going to get a 7. If I put in a 4, every time I'm going to get a 3. There's no other option for what I would get. So your range is allowed to repeat your outputs. However, your inputs should not be repeating. And that might be a little confusing at first, but we'll look at some other things that might help clear that up. Yeah, I'll go through it once I'm done with the lesson. The next thing that you need to know is graphing them. In fact, I'm actually going to draw some graphs here. So the next thing you need to know is your vertical line test. Your vertical line test is going to be able to tell from a graph if this is a function. So used on graphs, to tell if it's a function or not. So let's say we have a graph and you have your axis, that's really big. You have your axis there, and on your graph you have a line that's plotted and it's going like this. I don't know, I just made up a line. I drew a curve on that graph. You're going to take it through the vertical line test. I can ask you the question right now, is this a function? Meaning, does every x value have one y value? Have one y value? That's the question I'm asking. If every x value has one y value, then it's a function. So like this point right here, it has an x value of 1, 2, 3, 4, 5, 6, 7, -7, and it has a y value of -1. So if I plugged in to your table here, -7, put it into my function, it fits this line, it's going to come out as -1. There's my coordinate plane. It's part of a relation. Is there any other thing in that if I plug in -7, will I get a different answer? And that's going to be no, because the line only crosses this point at -7x. In other words, if you go with a vertical line test and you say, hey, can I draw a vertical line? And here's a vertical line. This is my line of symmetry, actually. If I draw a vertical line here, is it only going to pass through one point? So for a function, I got to get that off, or it's going to be weird. Vertical line only passes through one point is going to be a function. If it passes through more than one point, that means the input was able to give, or multiple inputs of the same number will give you multiple outcomes, and that's going to just be a relation. So if you were to take a vertical line and you can just drag it across here, you can see that at any point on this vertical line is going to intersect with my curve only at one specific spot, anywhere on this graph, no matter where I put that. So this is a function. I know that's a function. Let's get a different function here, or a different relation. What if we had just a plain line? We just have a straight line going through our graph. Again, you're going to look at a vertical line test. You're going to imagine a vertical line. As you go through this vertical line and move this vertical line anywhere on this graph, is it going to intersect with this line in more than one place? Yes or no? In this case, for a line, it's not, so this is a function as well. Of course, that's my symmetry tool, so it's doing weird things. So this is a function. So that's a function as well. Let's look at another one. What if we had a circle? There's the best circle. Actually, I can draw a better circle, can't I? Because I have a circle tool somewhere, don't I? What if it was a circle? Well, looking at your vertical line test, right? Can I draw this vertical line? If I put it here, you will note at this point and this point both intersect that vertical line. In that case, this would not be a function. And you can see it happens all over the place. This point and this point both intersect. That means at, let's say, x is -1, all right, let's put my line at -1 there, y is going to be either this number or this number. So if x here was -1, y could be -2, or y could be 1, 2, 3, 4, 5, 6, or +6. In that case, it's not. You are allowed to have vertical lines because they're going to be different x values. You are allowed to have the same kind of, you are allowed to have different x values have the same y value. So different inputs can have the same output. And we can give you an example of that too. See, I don't want that. Don't want that. I want that. And that would be, let's say you have a function equals x squared, right? You have a function of x squared. That's my rule. So f of x equals x squared, right? If I plug in 1 for x, so if I say 1 is in my domain, my x value is 1, my y value is going to be 1, right? So I can plot that point, 1, 1, which is right here. Right? But what if I say my x value is -1? Right? -1 squared is also 1, and that would be right here. And you'll see that does not pass your vertical line test or your horizontal line test, but it's still a function because it's going to pass your vertical line test. In fact, if I graph this out all the way, is that 4 and 4? Right, it's going to look like this. And in that case, you do get only one vertical line. However, the horizontal line doesn't matter. You can cross different places on that. The vertical line is all that matters for a function. And that goes back to your question the other day, actually. And the fact that, right, if you were walking from school or something, we were walking or something, you had this, and then you had a vertical line in your movement, and then that way, and this was distance, and this is time. This is saying you're at this point and this point at the same time. You're in two places at once, which doesn't make sense in the real life, and therefore it's not going to be a function because it has that vertical slope to it. So if you remember, I think it was Friday you were asking about that. But yeah, it's not going to be true because that's just not possible. So it's not going to be a function. We're not going to be able to get that. In fact, if it had that vertical line, any y value that this line goes over is a possible answer. And there's an infinite amount between there and there. Right. So Vertical line test, really simple tool to use, but very effective. If you look at the notes I had more of them here. So here you have your vertical line. Hey, here's just a normal line. It works. Your quadratic or your parabola, it will work. This looks like it might be a cubic function in some way. This might be some variation of a sine curve, but it all passes. Here, you'll note that vertical line does cross a couple of points. So these are not functions. Functions, not functions. And that's just by looking at the vertical line. Next thing on the list are equations. And I am going to do this, even though you might not see it on your work tonight. But I'm not going to be here tomorrow to talk you through things, so let's do one like this. Equations you've probably seen before. I mean, you've been solving them all last chapter, right? Let's say you have something like y equals 3x plus 2. This is a line. I know it's a line because I'm familiar with how lines work in functions, and I can tell just by looking at it that it's a line, and eventually you will be too. But it's really easy to figure out. You can actually graph this, and the way that you're going to graph this right now is by plugging and chugging it out. There are other ways to do this, but let's see if this is a function. This here is also the same thing as, again, f of x equals 3x plus 2. So you might see them written both ways. F of x is just your output, it's your y. So what you're going to do is you're going to set up an xy table. And you're just going to pick some values for x. It doesn't matter what values you pick for x, unless it specifically tells you, hey, you can't pick certain ones, like it will restrict its domain, which is possible. There are functions out there that do that. In fact, they're actually not that uncommon. But for a line's going to go through every single possible x value you can think of. So it's going to work for anything. You can pick any numbers you want here, but you pick your inputs. So if you think of a function as a machine, again, here's our little function machine. Your equation is the rule that goes in here. So this is going to be multiply by 3, add 2, add 2. Right? So if I put an input of 1, if my input of 1 goes in, what am I going to get? Well, if I plug in 1 for x, 1 times 3 is 3, 3 plus 2 is 5. I get 5 as an output. So my y value would be 5. And then that gives me an ordered pair that I can graph, 1, 5. So I'm going to come over to my graph. I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. And I got a dot right. Why do I not want to draw on my graph? Am I in the same layer? Oh, I'm behind. Not what I wanted. There's my dot. So there's the first dot for it. And then I'm going to pick another dot, maybe 2, and plug in for 2. So if I plug in 2 into my function, and again, it goes into this rule, so I'm solving 3 times 2 plus 2. Right, 3 times 2 is 6, plus 2 is 8. I get 8. So at 2, I'm at 1, 2, 3, 4, 5, 6, 7, 8. I'm up here. And if you recall from before, I told you you only needed 2 points to graph a line, or you needed 1 point in its slope, and we'll talk about slope later on. But you should see this is getting 8. And then you can just use, I don't know if I have a good line tool on this or not. I have the ruler. Right, you can use your ruler to draw a nice straight line the best you can. Not the best at using my tools. It's my pivot points here, isn't it? Can I move my pivot point? I don't know if I can move my pivot point, but there's your line. right? And that's going to go on forever. I don't think. Yeah, I gotta get a little older. So you have arrows on it, but there you go ahead. You can graph a line that way, and you know any value I pick. So if I wanted x equals -3, all what I do is I come over on my graph. 1, 2, 3 is here. Boom, that's this point down here. That's 1, 2, 3, 4, 5, 6, 7, 8. So I'm getting -8. Maybe. I don't know. Depends on how well my graph lined up. But if I plug in -3 here, I get -3 times 3 is -9. -9 plus 2 gives me -7. So it should be at -7. But you can get an idea of where it's going to be based off the graph. How much further do I want to go into it? I already went over that notation. Mapping diagrams. Does it ask you for mapping diagrams? Yeah, the first few are kind of mapping diagrams. I'll start walking you through your homework. So if you want to look at your assignment in your book, we can do that. I'm going to get rid of this. I don't think I need that. All right, so we're looking at, let's double check to make sure I'm doing the right one. I was doing the wrong thing for 8th grade today. I'm looking at 403, 1 to 22. And you're going to have 2 days to do this because I'm not going to be live streaming tomorrow, and I don't think anything new is going to unlock. So take your time, do these right. But number one, it gives you this diagram. It tells you your domain over here, and it tells you your range over here. And it lists your domain as -5, -2, 2, and 5. And it lists your range over here, which is -2 and 3. And it tells you if I plug in -5, I get -2. If I plug in -2, I get -2. If I plug in +2, I get 3. And if I plug in 5, I get 3 as well. And it's asking, is this a function? And what that means is every x value has one y value. So does every x value have one y value? So does -5 only go to one of these? And that's yes, it does. Because -5 only goes to -2. -2 only goes to -2. 2 only goes to 3. 5 only goes to 3. So this is a function. And it's asking you to say, hey, is this a function? And why? Because every x value has one y value. Is this due Wednesday? If you want to keep up with things, make this due. I don't remember what I have coming out on Wednesday. Try to get everything done by Friday. Different people have like different things they're doing. I mean, there's some families that have like 5 kids and they have to fight over computers right now. So it's tough to get everybody on board to everything. What do I have for tomorrow? Tomorrow I just have you doing some graphs. I have you graphing 4 functions tomorrow, which really is not hard. I just showed you how to do it. You make an XY table, pick some values for X, see what Y is, plot the point, draw the line. And I'm not collecting graphs, so it's just more practice. But here, every X value has one Y value, so it's a function. Number 2 is not a function, I think. Actually, no, number 2 is not a function because our domain here in our range, you can see that -4 is going to turn out as either -5 or -1. So -4 is pointing to 2. So these are allowed to point to 1. They are not allowed to point to 2. If everything over here only points to one thing over here, it's a function. If something over here points to more than one thing, it's not a function. Was it 2 and 6? So that's what it says. This is not a function. And why? Because negative 4 goes to more than one y value. That's a y value, and that's not a function. So that's how you tell those things. Those are pretty easy. So yeah, this one wouldn't be a function. And again, your x values can only go to one y value. They cannot go to more than one y value. 3 is not a function either. You're right. 3 is not a function because 6 can be either negative 2 or 0. So for 3, again, not a function. Y, 6 goes to more than one y value. Right? And again, if you think about that graphing wise, if 6 equals, was it negative 2 and 6 equals 0 on that, those are your coordinates. 6 at negative 2 is like down here, 6 at 0 is here. There's a vertical line right there. It's not going to pass your vertical line test. So, other ways to tell. I know there's like a handful of strange problems today. I am looking for your explanations too for things. Every one of these problems asks you to explain why, do so. For number 4, it just gives you as a set, so just pull your set apart. You'll note the weird bracket. I guess it should give you a weird bracket, yeah. Was it 3 and negative 1, 3 and 0, negative 3 and 4, and 3 and 8. And here your domain. I mean, you can tell right now this 3 has 3 different y values it's going to, but we can write it out. You can list your domain as 3 and negative 3 because you only have 3's for x values and negative 3 for y values. Your range is negative 1, 0, 4, and 8 because those are all your y values. 3 goes to negative 1, 3 goes to 0, and boom, right there you can see. And 3 goes to 8, and negative 3 goes to 4. So you can rewrite it out like that, but right away you see, hey, 3, negative 1, 3, 0. No, there you're getting different y values for what you put in. Let's do a word problem for Jack here. Number 6. This is going to go back to kind of what our visualization was from Monday, yesterday, and Friday. So if you want to, you can kind of sketch a graph on what this looks like. But we're looking at time you take to go to library as a function of distance. Time to distance. I'm going to take all the context out of that. I'm going to be like, this here is your x value, right? And I'm going to ask, can you be at 2 distances at the same time? And that answer is going to be no. So this is a function, right? So if you are 1 minute away, can you be 2 meters and 10 meters away at the same time? The answer is going to be no. You can't be in 2 places at once. And time is constantly going forward. So you can't do 2 things at the exact same time. It's just not possible. There has to be something for it. I mean, well, I guess you, yeah, you can argue that statement, but you can't be 2 different places at the same time. In a certain context, I guess, too, but it just doesn't make sense there. But if you were to think about how that is as a graph as well, you should note that, hey, you start off at home, you go to the library, you probably spend time at the library, then you come home, right? That does not, this will pass your vertical line test every time, right? It's not gonna be two values. So you kind of look at them to do it. What was it? Number 8 might be a little different. It depends on how you interpret it too. I mean, your explanation will tell you. 8 is talking about price as a function of length. So if you're buying cloth or something, they might sell it as $3 per yard or something. In that case, if you're buying like 2.5 yards, will that be the same cost as 3 yards? That depends on your interpretation of it. It might be for some stores. They might charge it, they might round it to the nearest length. It might not be for some stores. They might actually sit there and do the math and be like, well, if it's $3 a yard and you're buying 2.5 yards, they might actually just proportion that out and give you an answer. So that one, it depends on your explanation. For number 6, yeah, number 6 is going to be a function. You're going to have a hard time telling me it's not a function. This one here, it depends. You might need a little more information for that. I can see you explaining this as not being a function. And if you think of that as... Actually, no, you can't. I'm sorry. I can think of this as not being a line. 8 better be a function too. Or, I'm sorry, this is 7. I don't know what I'm doing. No, this is 8. Yeah, I'm looking at 8. 8's also going to be a function. I don't know what I'm talking about. Right? They're not going to be like, oh, this guy's buying 1 yard of fabric. His price is going to be different than, say, someone who's buying 1 yard of fabric. If you buy 1 yard of fabric, you pay one price. That's going to be that. 1 year subscription of your favorite magazine as a function of age of the subscriber. That would not be a function. They are not related. I mean, that's depends, right? If you're 7 years old, it costs $12, so to speak. If you're 8 years old, the subscriptions still cost $12. It's not going to cost different. So your price is $12 would be your domain. It's a function of subscriber. So number 7 would not be a function. Not a function. Right? Because price isn't going to change based off of someone's age. It's going to be a standard thing no matter how old you are. So you can think of it that way. For pretty much 11 through 22, it's graph them and then check the vertical line test. So plot the points, connect the points, and see if the vertical line goes through it. That should give you enough for today and tomorrow. Tomorrow you're going to get stuff like I did earlier, where it's going to say like y equals 3x plus 2, and it's going to ask you to graph this. I only gave you lines to graph, so everything should be a line, which means you need 2 points in order to graph, so you only have to do it twice. 9's a function, I didn't read it. It's the number of students on a field trip, a function of the number of buses used. Number 9, number of students, a function of the number of buses. Number of students, a function of the number of buses. Yeah. Students over here. Buses over here. If you have 3 students, right, you're not going to take more than 1 bus. If you have 4 students, you're still not going to take more than 1 bus. If you have 49 students, you probably need a second bus. So it's going to be a graph that looks like that. It's one of those piecewise things. This would be 48. I think buses hold like 48 kids, or something like that. I don't know. But that would be a function. So 9 is a function. You're not going to take you're not going to take 2 buses for 3 people if you could take 1 bus. It's just not going to happen. It's not. It's saying it's the other one, right? Number of students as a function of the number of buses. So f of x equals number of buses, just because of how it's worded. A function of the number of buses. So in this case, x would be your students. But yeah, if you did switch that, it would not be a function. So be careful with that. Again, try them. You're going to get 4 things to graph tomorrow. I'm not collecting graphs, but I got to end this. This has gone on too long, and I got to get to something else here. So no live stream tomorrow because I won't be home. Try them. I will go over them in more detail Thursday if you still have questions. But it's mostly terminology today. The math really isn't that difficult. It's just kind of applying definitions. So go over the notes again, rewatch this if you need it. I did do an example of graphing, so when tomorrow's comes out, you should be able to graph it. If you have graph paper, I highly suggest you use it. If not, you can always kind of eyeball it, but I am not going to sit there and read your graphs. I have a hard time reading some of your handwriting, let alone if you make a graph and then send it to me. So with that, so 10 isn't a function? I don't know. It's the number of buses used on the field trip, a function of the... Yeah, 10 would not be a function. It flips it around. Normally you put your independent variable on the bottom. So 10 would not be a function, but 9 is. All right, I'm going to end it. Have a good evening. I will talk to you Thursday.